Good afternoon, everyone. My name is Anton Jör. I work with Swiss Red Cross, and I'm very grateful to have this opportunity to exchange with you on the topic of soil bioengineering for DRR. I will do that on basis of a program, community-based disaster risk management program with the aim to increase resilience, where we integrated soil bioengineering measures. I will start just briefly with the context, then on the process, go through the typical measures that those communities apply, and then end with findings on impact. So, Honduras is one of the poorest countries in Central America. It is also one that is extremely exposed to a range of hazards, natural hazards and climate variability. It is also a country that is characterized by a lack of essential services, especially for communities for rural communities in remote areas. That's where the Red Cross is working. Furthermore, unsustainable use of natural resources, especially deforestation in those areas, population growth, and resettlements in high-risk areas are increasing exposure and vulnerability. Just a few words on what soil bioengineering is. I found a very straight-to-the-point definition. The use of living plant materials to provide some engineering function. An effective tool for treatment of a variety of unstable or eroding sites. And it has been used for many centuries and is still used all over the world. A few words to the process. In the municipalities where the Red Cross is working, the municipalities, they don't have precise information on the risk they are facing. So as a first step, we are supporting them in the risk assessment and risk mapping. We do that in a two-pronged approach. One community-based, so the communities they can do that, but it is also combined with risk studies by experts. We found that this interlinkage is a very important step. It helps for the communities. It creates a common understanding and helps for commitment of communities for the implementation of mitigation measures. Then, together with the communities or community members, the critical sites are identified where then the members of the communities want to work on. Mitigation measures are at the community level, small scale, but very broad in nature, and they are encompassing grey infrastructure as well as green infrastructure. But on the green infrastructure, that's now the focus. So I will go through one measure that is applied in the south of the country and three in the northeast of the country. In the south experiences for 2-3 years now heavy drought. So even though reforestation would be isn't very necessary, plants alternative techniques are necessary, and what we have now in a pilot is the use of Agua Salida, reforestation with Agua Salida, solid water, is also known as lluvia solida, solid rain. This is a potassium-based powder or granulate that has an incredible water intake, up to 5 times its size. And I brought a sample with me, and I would like to pass it on to you and pass it around. The first one, that's 10 grams of potassium needed for 1 plant. Please have a look and also grab it to see its texture if you don't know it. And that's then the same thing, 10 grams of the same material accumulated with water. You can also touch it. It's a bit funny at the beginning. Also, this technology, this Agua Salida, that's not a new technology. That's been around for some 10 years. And it has been developed by a Mexican chemist engineer. So great that I can present it here in Mexico. No? The name is Sergio Rico. So solid rain acts as a personal underground reservoir that retains water in the roots of any plant. This retained water is then slowly dispersed in the soil, keeping it constantly hydrated. I have to read that like this because that's a bit complicated. Solid rain helps making water available to any plant, even in times of droughts. So that's where we thought that could be a measure to be used there. And in the context where we use it, we have summers with temperatures up to the 40s, and humidity there. If you use this methodology, humidity is then retained in the soil and used and absorbed by the plants for 25 days. So this gives you a good frequency then for irrigation. Yeah? You don't have to go every day for every plant, but every 25 days for every plant. So that's a big difference, I think. Just whoever is here, you know, just please. I'm not going to take it home. We have used it now for 1 year, and despite a very strong summer and plagues, there's still 85% of the plants planted are still alive, of 10 hectares of a pilot in different regions, and at least we think this is a very, very good rate. Okay. In the other region, in the northeast, with more water, we apply other measures. One is drainage fascines. This is in slopes that are destabilized due to water accumulation. How does it work? Ditches are drawn in a fishbone pattern, as you can see on the picture on the left, filled with living fascines, picture on the right, and covered with earth. This allows drainage of the water to lower parts. The effects: it prevents saturation of the soils and the formation of incision due to surface runoff, and of course contributes to soil stabilization. Another wide used technology by the communities are oh, what happened? Help. So let's rush through again. There we go. Sorry. Our pile wall with plants. They are used in gullies. This methodology is used in gullies, as well in slopes made of loose material, which is susceptible to erosion. How does this work? Cuttings of living plants with high ability to convert into shrubs and trees are used. They are driven into the ground and braced with branches horizontally to form a barrier in the slope or in the gully. Effects: retain loose material behind the walls, prevents the formation of the gullies, and reduces bed erosion in the gullies. The last measure I would like to highlight is contour planting. This is applied in slopes susceptible to shallow landslides. And how does this work? Species with abundant and profound roots, such as vetiver. We found that vetiver in this region is a very good plant, very well adapted for that, are planted along the contour lines. They contribute to improved soil cohesion, aeration, infiltration, and distribution of humidity. The effects: prevents channel formation, prevents erosion of topsoil, retains shallow landslides. So why did I present that? In this context of community-based resilience building, we found that those measures, thank you, they are low cost, they are low tech. The farmers, they need a certain introduction which they receive, technical support by the community, by the project. It's based on locally available plants, and it's easy to maintain. So this is a favorable environment for the farmers, and using that has converted the once risk areas into spaces of opportunity. Usually vegetable gardens to grow vegetables, to also grow medicinal plants. What else? Fruit trees, and part of that can be is also sold in local markets. So we have there, apart from homestead protection, we have benefits in health, in income generation, and in a retransfer to reproductive land. As well as it is low tech, etc., we have noted that very high self-propelling effect is ongoing in those communities. So communities apply it, families see it, others come and are interested, they are helped by those families, and they replicate it. Entire communities are doing that. Neighboring communities are also starting to do that. It is something that is supported by the project technically and not financially. They can do that by themselves. And we have also noted that even applied for homestead protection, many farmers are now also introducing it into their agriculture, in their agricultural land. Time, yeah, is almost up. So that's my last slide. Information is available. You can have some samples here. I brought it with me. A case study on it in English, a manual on it in Spanish. It's also uploaded in this resource package in GPDRR. And just an information of an upcoming, thank you, an upcoming, sorry. Publication. The Swiss Red Cross is part of the Swiss NGO DRR platform, and in a joint effort with the University of Bern, we are producing a compendium of good DRR practices that will be published in a book, but is also integrated in the WCAT database, World Overview of Conservation Approaches and Technologies. I think a very good database, and much of what is in there deals with soil bioengineering. Thank you very much for your attention.